Hello everyone, welcome to the channel and I hope everyone is doing good. So today's video is going to be regarding MCP, Model Context Protocol. So I'll tell you my experience, like when I interact with multiple people who has moved into GenAI from the data engineering experience. So they understand RAG application, they are able to build the RAG application. But most of the people I have seen that they don't understand MCP. They have an overview of MCP. They have gone through multiple videos, gone through some of the vlog, but they don't have any experience in MCP. This is the first thing. The second thing, they don't understand the behind the scene, what MCP is and how it works. So then, and this creates a problem in the interview process. So in the interview, these kind of candidate is able to answer few of the MCP related interview questions, which are the textbook based questions. But if there's a cross question regarding MCP, working of the MCP, the use case of the MCP, what happens inside it, then it creates a problem for this kind of candidate. So I thought of bringing up a video in which I'll clearly and very easily explain what is MCP in very easy way. So this video is going to be very easy, and this video will give you the full context of what is MCP, where to use it, and what happens behind the scene, who creates what and who uses what component of this MCP. So stay tuned till the end of this video. You will get to know MCP in more detail and in a better way. If you have not subscribed to our channel, please do subscribe to our channel and please share this channel and this video to all your colleagues and friends who want to move into data engineering field or who are already a data engineer and want to move into the Gen AI field. So let's start the video. So directly going into what is MCP, I want to discuss about what is the problem area and what is the problem in our understanding regarding the LLM and what problem this MCP solves, like what is the solution MCP comes with. So now you can see on the screen, like there's an AI application, then there are few external tools like GitHub tools, Snowflake and Gmail. Now, what generally people think is your LLM directly connects to the GitHub or your LLM directly connect to the Gmail and get the answer. But that doesn't happen. LLM don't have the capability to connect to any external tool. LLM is just a model which is being trained with multiple things, multiple data. You can consider LLM as a brain. This brain cannot directly connect with these external devices or external tools. So the first misunderstanding which we have is like AI application through LLM connects to the external devices, or AI application, agentic AI application through LLM connects to external devices or external tool is wrong. LLM doesn't connect to the external device. This is the first thing. The second thing which I want to discuss is what are the problem areas, why we need MCP. So first we'll see one by one the problem areas, and then you will slowly understand that these are the problem areas, and then you need something which will solve this. So we'll come to the problem area. So now every application developer or the application owner build application and the agentic AI in this similar fashion. Like there's an application, there will be Python code which will be using LLM through OpenAI or Claude API. So I'm considering that OpenAI is being used. And now when you are using LLM, then you have to interact with multiple tools like Gmail, Slack, and database. So what happens traditionally, you have to write a Python code to connect to each of the API. Like you will call Gmail API with one of the Python code. You will call Slack API with another Python code, or you will create a connector to some of the database. So you will have to write this Python code to connect to all these external tools. Your LLM is not going to connect to the Gmail directly. So there will be a Python decider. Python decider means there will be some switch function, or anyway, you will write something by which you will get the input from the LLM, and that keyword is used to search in the Python code that which API has to use. So this was the traditional way where we used to call the external tool when we are using any AI application. Now this creates a problem. So now, for example, your AI application wants to use multiple external tool, or your AI assistant want to use multiple things. So like the first is Gmail, then you have a Slack, you have a GitHub. So these are the external tool which your AI assistant or your AI application is going to use. So now, as I have mentioned, LLM doesn't connect to these external tools. So who connect to this? So you have to write a code, you have to write a Python code to connect to this. For example, there is a Gmail API available. So you have to write a code which will give input to the API call of the Gmail. Similarly, if you have to connect to Snowflake, there is a Snowflake connector. You have to connect to AWS. You have to connect to AWS the ways the AWS has decided. They're calling that API. Now, for each of these external tool or external devices, you have to write multiple Python code. For example, gmail.py, slack.py. So who is going to write this Python code? The developer who is building the AI application. So that development team has to write all this Python code so that each Python code will connect to the specific external tool. For example, snowflake.py will connect to the Snowflake. It will not connect to the AWS. So you see that if you increase the number of tool, then you have to write a multiple Python code. If tomorrow your number of tools increases in your AI application, so then you have to again write that extra Python code. Now, see the problem here for each connector. For each connector, for example, you are connecting to Snowflake, you are connecting to Postgres. So for each connector, you will have a separate authentication. You will have the API calls. You have a error handling, pagination if it is required, retry logic, documentation. So all that normal engineering process has to be included for each of the Python code, and this creates a problem. Like tomorrow you don't want to use OpenAI, you want to use Claude, you want to some other LLM model. So in that case you have to change all this Python code. Second thing, if you want to change the authentication way, so you have to change the Python code. If any external team or some other team of your same account, the same project, there may be multiple application team. So another application team wants to connect to the Gmail with some other AI application. So that team has to again write that logic, and that logic may be different from what you have written. So there is no reusability of this Python code. So this is a huge problem maintaining this each Python code, because not each Python code will be under the responsibility of the application development team, and brings a huge overburden to the application development team. So this is the biggest problem. Now you see that enterprise level what problem is there and how it is solved with the help of MCP. A simple enterprise level problem is, like for example, there is an insurance company which is building an AI assistant, and the assistant should read the customer email, fetch the claim details, query the Snowflake or any other database where the claims detail is, create the ticket, Jira ticket, send Slack message, and then update the Salesforce. So, for example, regarding any claims, any issue has been raised by the customer. So, AI assistants to get into that support Gmail or email, any of the mailing service, get the detail of that problem statement, create a ticket, and assign to the particular team. So for this, if you want to build this AI assistant without the use of MCP, then you have to write each integration. Like for example, writing the integration to connect to the email, writing an integration to get the detail from the email, and then get connecting to the Snowflake with that detail. So for each process, you have to write the custom or manual integration. Every AI application repeats the same effort. Like one of the AI application in this insurance company using this, the other AI application wants to use some part of this, then also that particular another AI application has to repeat the same process. They have to write each integration again and again, and there is a huge maintenance. It becomes expensive and it becomes overburden. Now, to reduce this effort and moreover to reduce this complexity, so we have an MCP. So what we are missing in this whole scenario, which I'm talking since last 5 minutes, without MCP, there is a problem. So what is there something which is missing in this full story, which will bring MCP into the picture? We'll see now. So what is missing in this full story? The communication or the standard communication between the LLM and the external tool, that is missing. Now you see this LLM tells like which tool it has to create. It has to connect, but it doesn't connect to the tool. You have a Python code where this deciding factor is fed into that Python code, and that code connects to the external tools. So there is a gap between this LLM and the external tools. How to connect to it? There is no standard format. For example, you want to some company want to connect to Gmail, so it has the tool Gmail obviously, and the query it can write find invoice. The other company can tell invoice search So there is no standard way of doing it. Each company is writing in their own way to call the Gmail API. So this is getting repeated. What if Gmail comes with something which solve all this problem? If Gmail comes with a normal MCP server, like everyone has to connect to through this MCP server, and that will connect to the other services of the Gmail and gives you the result. So this way, there are multiple ways MCP can be created. I'll come to that. I'm not going to go into that detail right now. But just the problem, I think you would have understood. There's a gap between the standard gap, communication gap between the LM and the HTML2. Fine. So now how MCP solve this? Now you see, MCP clearly defines a process or a standard way how you can connect to multiple things. So MCP defines the standard language between the AI model and the external tool. So instead of every company inventing their own protocol to connect to the external tools, so it follows the same protocol. For example, the user like there is using an AI application. So there is an MCP client. Now there is an MCP server which connects to different tools. Now, what you've seen in the previous example, that you want to connect to Gmail, you want to connect to Snowflake, GitHub, Slack, or some other database. So you have to write a separate Python connector to each of these services, or you have to write a separate API call. Now, all this logic is written into this MCP server. Now, for example, there is your company has created the MCP server to connect to a set of tools. Now, all the application in your company can use the same MCP server to connect to different tools. So each of the application team don't need to write the logic to connect to different tools. So this MCP server has the logic to connect to different tools. So what Python connector I was talking about, or API call, all this logic is embedded into this MCP server. See, actually, the behind the scene, the things happen the same, what we have seen in the problem statement. But now all that problem has been clubbed into a single unified way, that is MCP server. So you don't need to know that how this MCP server is calling Gmail or connecting to Snowflake. You just need to give the instruction to the MCP server and it will connect to the external tool and get back to the result. Now, this MCP server can be created from the application development team. It can be created from the product team also. For example, GitHub will have their own MCP server. The Gmail can have their own MCP server, so that different vendor, different customer of the Gmail can use the same protocol, unified protocol of that MCP server to get all the services information or data information of the Gmail, which is available from the Gmail server. Now, you see this in this flow, MCP flow, there is no LLM getting connected to Gmail. Yes, LLM is there in the flow. I'll explain later in this video that where does LLM lies. But you see there is no LLM which is connected to the different tools. So now one thing is very clear, like LLM does not have the capability to connect to any external tool. It is just a model which is pre-trained with different data, billions of data. So now this is the complete flow how the AI application works when you're using MCP. So user is connected to the LLM. Now you fire the query like I want to connect to the LLM. I want to connect to the Snowflake. So LLM decide that it wants to connect to the Snowflake. Now this message is passed to MCP client. The MCP client has the information of MCP server. So that information is passed to MCP server. MCP server has the capabilities to connect to the Snowflake API. It connects to Snowflake API, get the result, and then the result is returned back to the MCP server. MCP server gives back to a result to the LLM, and that LLM give the result back to the user. Now, you would have remembered about the RAG system. In RAG system, what happens? The output which you get from the retrieve from the vector database when you retrieve, that output is first given to LLM. LLM form the complete answer with its intelligence, and then that answer is given to the user. Here also, when you get the output from the MCP server, it gets into LLM, and then LLM decide how to form the answer in a proper way, and that answer is given to the user as a result. So nowhere LLM is calling the API. So does LLM calls API? No, LLM never performs the REST call. LLM just decide, or it says that which tool it has to use. For example, execute SQL means you have to execute the SQL connected with some database. MCP client receives the request from the LLM and that is passed to the MCP server. Now the big question is, who calls all this API, like Snowflake API, and maybe tomorrow you want to call to Gmail API. So who calls this? MCP server. So all the logic of connecting to the database, calling the API, file format, getting the answer, everything is unified in a MCP server. So MCP server contains all this logic. You don't need to rewrite this logic again and again. So if I have Snowflake here, now if I have something, if I can write it here, for example, I'll write it here, Oracle. So this single MCP server will be sufficient to connect to Oracle also and Snowflake as per the requirement. Like tomorrow, the requirement is I need Oracle. So the same MCP server will connect to the Oracle API. You don't need to write any logic for it. You are just changing the prompt, you're changing the query, and MCP server is behaving in a different way. And you will not come to know that what is happening inside the MCP server. I mean to say that LLM doesn't know that what happens inside the MCP server. LLM just gives the instruction and it gets the output, and then it forms the answer and gives the answer as a result to the user. I hope I have made it very simple. I hope you would have understood what is this all about and why we need MCP. Now tomorrow I need Postgres. So I'll write it here, Postgres, MCP server. And one thing is more, one thing I want to add, like MCP server should have the capability. Like for example, I have 4 tools. And today MCP server has the capability to connect to the 4 tools. Then you can give the query regarding these 4 tools. Now tomorrow you want to have another 5th tool, for example, any other services, for example, you want to connect to Teradata. So that capability has to be developed inside the MCP server. So as a MCP server developer, you need to add that capability, and then it can be reused into multiple AI applications. Now, after understanding all this concept and why we need MCP, what is the problem area, there are few questions still it has not been answered in this video. The first is, do we need API? We have the MCP server. So if we have the MCP server, if then also do we need an API? Who creates this API if we need that? Who built the MCP server, and what does the MCP server exposes? It connects to Snowflake, but what it exposes, we need to look into it. So the first question is, do we need API? Yes, we may need API or we may not need API. There is no correct yes or no answer for this. Now, for example, you want to connect to Slack, you want to connect to GitHub. So it has their own API. So you don't need to, you don't need API. You can directly connect to the MCP server of that particular product. But in case you are building some application, you have a product inside your organization. For example, a banking organization can have credit spending behavior. It will have some dimension of the customer information or multiple information in the banking. Creating an account, getting the updation of that account. So for all these are the internal things, and for this, someone has to create an API for that. And MCP server will consume this API for the AI application developer. So now, who creates this MCPI? Who create this API? The person who is building the particular application or particular system. I'm not talking about the AI application. I'm talking about, for example, in the banking system, you will have one services for creating an account. You will have one services for creating a ticket. You will have one services for the claims and something. So for that purpose, the developer, the backend developer, need to create an API for all these services. And this API will be combined into MCP server. So MCP server can be built by these backend people also, or it can be built by the AI application to consume all this API. Okay. So yes, we may need an API, we may don't need an API depending on the scenario. Who creates these API? The product owner can create that API, or if you have an internal system, that will backend people will create an API who build the MCP server. Sometime AI application developer build the MCP server and it consumes all the API if it is internal. If it is a product, for example, Gmail, Slack, or some other tool for Facebook, so they may also create their they also create their MCP server. You just need to connect to their MCP server. Now we'll see that what does an MCP server exposes, what lies inside it. So what does an MCP server exposes? It will have a set of tools. For example, run SQL, create ticket, send email. So all that, like what are functionality inside MCP server, it differs from one MCP server to different MCP server. So it will have all this tool. It will have some of the documentation, internal documentation. For example, you build your own MCP server for a banking application or banking system. So for that, there can be a customer handbook, there can be product documentation, policies, PDF files. Then MCP server also contains some of the reusable template, prompt template, like how to summarize the meeting, how to generate the SQL, explain the error. So all this information, although this can be done with the help of LLM also, but that prompt will go to the LLM itself. But there is a generic prompt, or the reusable prompt is stored in the MCP server. So when an AI application developer creates its own application server to consume all of the companies or the backend APIs, then it is more customizable, and you can create your own way of MCP server by putting more of the context, by putting more of the documents inside that, creating more of the reusable prompt inside that. So it becomes more customization when you create your own MCP server. I hope by the end of this video or this session, you would understand that what MCP server is in a very detailed and very easy way. After this video, I don't think you will be having any problem in understanding the MCP server. For setting MCP server or more complexity of the MCP server, there is still an open question. But the understanding of the MCP server must be clear after this video. Still, if you have any doubt regarding MCP server understanding in the concept, please put it in the comment. You can mail me, you can directly connect me through the LinkedIn. In the next video, I'll come up with the MCP interview questions, which will still focus on the basics of the MCP, the fundamentals of MCP, but it will more focus towards the interview pattern, what the normal interview pattern is regarding the MCP. So after RAG, now the interview is shifting towards RAG plus MCP, and slowly it will grow as the GenAI system proves itself in multiple of the subdomain. If you have any doubt, please comment. If you like the video, please like the video. Give the feedback in the comment. Share it with your friends or colleagues. And we'll meet in the next video. Till then, goodbye and happy learning.